I'd like to describe here what it means when I say pull the constant through the derivative. So here's an example of a function, and I want to take the derivative. So I want to have derivative of y with respect to x of this side, and that is going to equal the derivative with respect to x of this big y, 2x squared sine x. So when I'm taking the derivative of this, and I could have written it, y prime equals, and then I'm figuring out what is the derivative of this. So either way, it doesn't really matter. I'm just having to use this particular notation right now. What I have here is I have a product. I have 2 times x squared times sine x. And if I have a product like that, it would be UVZ plus UVZ plus UVZ, and I'm just going to move the prime back through each one. So I'd be adding them all together. So let's kind of do it the long way. So u prime, so let's go. Here's u, here's v, and here's z. So u prime, well, the derivative of 2 is 0. So it's 0 times x squared sine x plus, now I have u times the derivative of v and then z, so u is 2, times the derivative of v, which is 2x, times z, which is sine x, plus, now I have uvz, so it's 2x squared, and the derivative of sine x is cosine x. So I'm adding all those things together. Now, 0 times anything is 0, so that goes away. So now I'm looking at a derivative of 2 times 2x sine x and 2 times x squared cosine x. So how about if I just factor out a 2, and then I have 2x sine x plus x squared cosine x. And I can simplify that a little bit more, but I'm not going to right now. I just want to leave it like that. So this is my y prime. Well, let's look at it. If I had just pulled the derivative pull the constant through the derivative. So I'm going to paste. Here's my function right now. Now I'm doing y prime. What I'm going to call it, I'll call it y prime. And that is equal to, now, I'm actually going to use the other notation. It works better in this situation. So derivative of y with respect to x is equal to, so it's the derivative with respect to x of 2 times x squared times sine x. And what I'm going to do is I'm going to pull the constant, that is my 2, through the derivative. So I'm going to put it at the front now. So dy to dx is equal to 2 times the derivative with respect to x of simply x squared sine x. Now I still have a product right here, but instead of doing UVZ, I can just do UV plus UV. And let's do that. So I have 2 times, well, again, u prime is 2x times sine x, plus u, which is x squared, times the derivative of sine x, which is cosine x. And if I'm not mistaken, this right here is exactly the same as this right here. So I'm looking at the very bottom here. This is what we just came up with after pulling the constant through the derivative. And I get the same answer as I got before when I had that whole extra step. So that's what I mean by pulling the constant through the derivative. I don't have to go through that extra step. I know it's going to end up at the front.